All right, so this is Unit 10 review notes. So these are just a quick reminder of how Unit 10 is going down. This is your second to last assignment. You're almost done. So let's just get through this. Hopefully this is a great review for you. So first off, we need to remember our special right triangles, specifically those with a 30, 60, 90, and a 45, 45, 90. Okay, we need to remember what those are. Okay, and in that case, it's just remembering the 1, 2, 3. For the 30, 60, 90, we need to remember that we have a 1, a 2, and a square root of 3. 3 is always with the 30. With our 45, 45, 90, we need to remember 1, 1 square root of 2. So the 1s and 1s are there, and the square root of 2 is there. So just as a quick reminder of what those are. Remembering our law of sines, remembering that it is sine of angle A over side length A is equal to sine of angle B over side length B, and is equal to sine of angle C over side length C. Remembering those. Law of cosines, I'm only going to put one down, and that's the one where it says c squared equals a squared plus b squared minus 2ab cosine of c. So AB's are in here while the C's are the outsiders. Remember, this is what you're using it to solve for, either the side length C or the angle C. So those are really important and things to remember. We're going to do a few examples just as a way to be like, oh yeah, this is how it works. And then you have your review packet to do it. Our first example is a lovely word problem where we are looking at an airplane that has an altitude of 1,200 meters. So it is really up there. The angle of depression of a rock on the ground, so we have a rock on the ground, creating our triangle here, but it said angle of depression, so it's looking from the horizontal down of 28 degrees. And we need to find the distance from the plane to the rock. So this is what we're looking for. So our angle of depression says here it is at 28 degrees. That is the same thing as our angle of elevation, which then tells us since we have our angle inside of the triangle, we need to look at what the 1,200 and the x represent. Since x is across from the 90, this is our hypotenuse. 28 is still across, it's not touching the 1,200, so this is opposite. So we're looking at O and H, which means we're looking at so. So that means we're going to say sine of 28 equals opposite of the 1,200 over our unknown x. Remembering our lovely cross multiplication skills, or understanding that x and sine of 28 just switch spots. X is going to equal 1,200 divided by sine of 28. And when you plug that into your lovely calculator, you should be getting 2,556.06, and we were in meters. So just remembering angle of depression. Please don't forget SOHCAHTOA. It still exists. I think a few of you were doing law of sines for right angles when just do SOHCAHTOA. You got those down. Do that one. Example 2. So we were given an angle of 30, two side lengths, and we need to find all possible measures of B. Well, from my standpoint, since I know this is find all possible measures of B, that means I am going to be using law of sines. So I see that A and A correlate, so we have sine of angle A over sine length A has to equal our sine, our unknown B angle over 10, since that was our B side. We're going to cross multiply, and we're going to see that 6 sine of B equals 10 sine of 30. We're going to divide by 6, so sine of B equals 10 sine of 30 divided by 6. Can't do a sin, so you have to do sine inverse, so B equals sine inverse of 10 sine of 30 over 6. You're going to plug that into your calculator. Make sure your numerator is in parentheses. You're going to get that it is about 56.4 degrees. That is one angle. We now need to find the second possible angle. So the second possible angle says we take 180 minus 56.4. That is equal to 123.6 degrees. Now what we need to understand is, does it work? So we take 123.6, we're going to add the given angle, so 30, and we're going to see that this is 153.6. Since this is less than 180, both 123.6 and 56.4 are equal to each other. Okay? Well, they're not equal, those are the possible measures of it. B. Miswording. So for example 3, we're going to solve the triangle. Well, since it says solve the triangle, it means I have to find all pieces of missing information. So I'm just going to make a nice, lovely triangle. Label it D, E, and F. And then I'm going to look at what I've been given. Side F is 19 feet. Side D is 13 feet. And angle E is 20 degrees. So we need to find angle D, angle F, and side length E. So we have 3 things we have to find. Since I was given side, angle, side, I should see that because I need to find the side length, I'm going to be using the law of cosines. So I'm going to see that this is going to be E squared equal to my 19 squared plus 13 squared minus 2 times 19 times 13 cosine of 20. This is a straight plug and chug as long as you're plugging in everything correctly. You'll get that E squared is equal to 65 approximately 0.79, so E equals 8.11. Now that we know that E equals 8.11, we have side lengths and a correlating angle, meaning I can use law of sines. So I'm going to do sine of 20 over 8.11 equal to sine of D, just chose D, 13. I cross multiply and notice that when I plug this all in, it should be sine inverse of 13 sine of 20 divided by 8.11. Plugging it into your calculator, you're going to see that it is approximately 33.2 degrees. And that's pretty decent because 8.11 is with 20, 13 is with 33.2, so those are just slightly bigger. So that means our 19 is big. That's our angle-side relationship correlation. But to find F, we're going to take 180 minus our 20 and minus our 33.2. So F is going to equal 126.8 degrees. You have to find the 3 pieces of information when it says solve a triangle. You cannot solve one and expect to get full credit for that. Okay. All right. Moving on, once again, we are solving a triangle, this time ABC. Creating that lovely triangle, A, B, and C. We're going to label what we've been given. We saw A is 12 inches, B is 10 inches, and C is 15 inches. Okay. I've been given 3 side lengths. That means I have to use law of cosine. Well, remember when we're using law of cosine and we are not given an angle, we need to find the largest angle. And it should correlate with the largest side. So we're going to be looking for C first. So knowing that we're looking for C first, we start with 15 squared equals 12 squared plus 10 squared minus 2 times 12 times 10 cosine of our unknown C. So we should be taking 15 squared, we're going to subtract 12 squared and 10 squared, you get negative 19. We're going to see that 2 times 12 times 10 is negative 240 cosine of C. We should divide by negative 240, so I'm just going to leave it at 19 over 240 just because it's prettier than all the decimals you're going to get. And to get to C by itself, we say C is equal to the inverse of the cosine of 19 over 240, where angle C is going to equal 85.5 degrees. So we now know angle C. Well, it said solve the triangle, meaning we still have to find A and B. Well, now that we have an angle, we can now use the law of sines. So I'm going to do sine of 85.5 over its correlating C of 15. And I'm going to solve for A. So sine of A and its correlating of 12. You cross multiply, you'll divide by 15, and you're going to see that A is equal to the sine inverse of 12 sine of 85.5 divided by 15, and A is going to equal 52.9 degrees. Now that you have A and C, all you have to do to find B is take 180 and minus the 2 degrees we just solved, and we're going to see that it's going to equal 41.6 degrees. So we got A, B, and C. Okay. Making sure when you solve a triangle, you solve the whole triangle. Next to my absolute favorites, converting to degrees and radians. So we have a lovely radian and we need to convert it to degrees, so we're going to multiply it by our conversion factor of 180 divided by pi, because our pi's will cancel. Take 2 times 180 and divide by 5, and you're going to get that it is 72 degrees. Our next one, we're converting negative 120 to radians, so we take negative 120 times our opposite conversion factor of pi over 180, because we need pi for our radians. Take 120 divided by 180, press map and frac. You're going to get that it is 2/3, so our problem is negative, it's still negative, 2 pi over 3. Making sure we remember all of our conversion factors. This will help you so much in trig. Okay. So now we need to draw the angle and tell the reference angle for 7 pi over 4. So I know a lot of you are converting. Please stop doing it. Please. So what you need to do is you need to try and get this as close as possible to either pi or 2 pi. So we look at the denominator and we say, is it closer to 4 pi over 4, which is pi, or 8 pi over 4, which is 2 pi? Well, 7 is definitely closer to 8 pi over 4. So we know it has to be coming around here and getting closer and closer to this area. So we know it is in this quadrant, because 8 pi over 4, 7 pi over 4 is over here. And we need to see the difference between 8 pi over 4 and 7 pi over 4. Well, it's only a pi over 4, so our reference angle is pi over 4. Okay. So these next ones we need to evaluate. These ones are evaluations of our quadrantal, I think that's how you pronounce it, reference angles. So we have tangent 180. Well, 180 is half of pi. Or no, it is pi, it's half a circle. So it's this point right here, which this point, if you remember, is a negative 1x, but 0y. Now that we have this point, we need to remember that what tangent is. And tangent is y over x. So what we're going to do is we're going to take our y of 0 and divide by our x of negative 1 to get that tangent of 180 is 0. We're going to do the same thing over here, but now we're looking at radians with sine of 3 pi over 2. We know that a full pi is 2 pi over 2 because of the denominator. So that means another half of pi means we are down here in this area. This area says we are at 0, negative 1. We need to remember what sine is. Sine is y over r. So we take our y, which is negative 1, and remember our r is always 1, so we divide by 1. So negative 1 divided by 1 is negative 1. Just 2 more quick examples and you are off to the races with your Unit 10 review. And we are evaluating by drawing the special right triangles and telling the reference angles. So first off, cosine of negative 405. Not going to even look at cosine right now, but I need to look at negative 405. So we need to remember that since this is larger than 360, we should add 360 and or subtract depending on what it is, and see how close it is to there. So when we subtract, we're going to see that this is negative 45 degrees. Well, it's actually quite helpful. So what this says is we take our angle, we go 360, I went the wrong way because it's negative, 360 and an extra 45. So that says that we are right here in this quadrant. So we knew this was a negative 360. We had to go another negative 45 to get 405 degrees. Remember, always when you create your triangles, it has to touch the x-axis, creating your lovely triangle. We need to figure out this reference angle. Our reference angle, again, is the difference between your original and what your x-axis is. Well, we already did that. It was negative 45. But remember, reference angle is always a positive. So this is a positive 45 degrees, so that must mean this is 45 degrees. Remembering our special right triangles, it is 1 square root of 2. Now we have to look at the quadrant. We are in the positive x's, but we are in the negative y, so this has to be a negative 1. We have created our special right triangle. We told the reference angle. Now we evaluate using our cosine. This is where we need to remember that cosine is x over r. So our x value is 1, and our r value is the square root of 2. We don't like that. No rationals in the denominator. So we're going to multiply by the square root of 2 over the square root of 2. And we're going to see that it's going to equal the square root of 2 over 2. So cosine of negative 405 is the square root of 2 over 2. Our last example for Unit 10, 5 pi over 3. Ask yourself, are you closer to 3 pi over 3 or 6 pi over 3? Always go by the denominator. 5 is much closer to 6, so that means we are going to be looking right here for our 6 pi over 3, knowing that we have to start here and work our way this way. 5 pi over 3, since we're not getting to 6, has to be in this area to create our lovely triangle, because this has to be 6 pi over 3. So we now need our reference angle. Our reference angle is the difference between the closest x-axis and our angle. We can see we are 1 pi over 3 away. Well, that doesn't help us with our special right triangles. So you convert it by multiplying it by 180 divided by pi, and you're going to see that it is a reference angle of 60 degrees, and it is always this one up here that is closest to the origin. So this means we have a 30, 60, 90 triangle, and we need to make sure we accurately put our stuff up. Remember 1, 2 square root of 3. So 1 is with 60, 2 is our radius, and the square root of 3 is always with our 30. Now that we've put our numbers where they're supposed to be, we need to make sure and check to see if any of them are negative. We are in the positive x's, but we're in the negative y's. So this is a negative square root of 3. Well, now we need to look at tangent, specifically tangent. Tangent is y over x. So now that we know that it's y over x, we find our y, which is in the negative square root of 3 over our x of 1. So that just means that our answer is negative square root of 3. If you have any questions, please let me know. I think you'll all do just fine. After this, we just have a final review, and you are done for the year.